The Remington Core-Lokt is probably the most well-known bullet in the history of hunting, and all of them come from right here. This is the Remington Ammunition factory in Lonoke, Arkansas. But they do a lot more than the Core-Lokt. They make centerfire rifle ammunition and centerfire pistol ammunition. They do it all. And we're going to take you behind the scenes to show you the entire process.
The way the plant was set up when it was built in the late 1960s was such that it was very much optimized to bring raw material in one side of the plant and work your way towards the center of the plant. And each one of those processes has stayed fairly much true to the process that was originally set up.
We're getting reclaimed recycled lead, so we're not using fresh lead out of the ground. We're getting recycled materials. So that's got to be heated up to a melting point. We're going to change the shape of it again to a bar stock. So that bar stock is the cylinder, so we can then run it through the extruders to a wire form. After you get the diameter that you're after for whatever specific bullets we're needing, slugs are going to be cut and they're going to be put in the cores of a jacket, a copper jacket or a brass jacket, depending on what bullet we're making at that time. So on the bullet area, we're bringing raw materials in a strip form. We're going to punch that out into a cup. That cup is then going to flow and meet up with that slug that we cut off from the entry to the plant, the raw material side. Those two are going to meet in a process, and the machine's going to shape the nose of the bullet. We're going to insert the core. We're going to fold the heel around on it. Depending on what bullet made, that determines how many steps it's take. We're just moving metal, so it's a lot of noise and a lot of pounding to get it in that shape to put it in the shell.
As far as primer manufacturing, we make all the primers for centerfire, pistol, and rifle ammunition. You have two distinct sizes of primers. You have a small, which will come in your small pistol and small rifle. Then you have your larger centerfire primer, which is for your larger pistol. And then you also have your large rifle primer as well. Obviously, we make several different variations depending on load application, right? So there's a lot of different things there as well. Everything, even to a lead-free configuration, we make that also.
So a shell case can come in two forms. We'll get it in that strip of brass, or we can buy the cups already stamped out in a specific size for larger Magnum type rifle cups. It just saves us a step. We're going to extrude that to the length we're going to need. One of the interesting things where you start seeing the shape of the shell is when we start putting the head step and the primer pocket in there. So we're using a bunter in that process. A bunter is a tool that is made to a print that has the font or head stamp of the cartridge that we're making at that time. So after the primer pocket is in there and we've head stamped it, we're, depending on if it's a pistol cartridge or a rifle cartridge, a pistol, we're getting close to finishing it. We got to clean up the mouth. We got to put the extractor groove on both of those shells. With the pistol shell, we're basically finished. A rifle shell that has a shoulder, we've got a few more steps. After we've cut the groove in that shell, we got to run it through the annealers so we can soften up the shoulders on those things. Because if you're going to work them at that point, that brass can harden itself with the working of the tooling and become brittle. And you don't want shoulder splits when you're firing the rifle. So now the interesting things happen where things can go boom. So we pierce the shell and put a primer in it in one operation. So in that room, we have a series of detects on machines to validate that hole is in place and the primer is in place, because that is a critical component to the round. Everybody's concerned about their bullet and the powder and the shell itself, but without a flash hole, you don't get any fire to the propellant. So that is a critical thing that we check. We want to make sure of. After you've got the primer in there, that shell is ready to go to loading.
Our centerfire lines here at Remington, we have an old legacy process that married both of those up in a Mandarin style loader. That loader goes through and gets packed up in an automated packing system. So it's a great marriage of old technology that's been used, tried and true, and sent out billions of rounds of fantastic ammunition throughout the years. We also have a new facility that we're using that is a very lean approach to making ammunition. By far the leanest in the world right now, and that's taking raw material in, feeding that into the line, and so we have raw material inputs, whether it's bullet or brass, and those bullets are all ran at the exact same time. They get primed, they get sent through a loader. That loader goes through a packer, and it ends up on a pallet. And so within an hour, we have raw material being turned into finished product sitting on a pallet. And so it's really neat to see that there's two different methods to get to the same conclusion, which is a fantastic product.
In ballistics, we're really the last stop before our ammunition goes into a box and is stacked on a pallet for a truck. We have anywhere from 20 to 30 gunners around the shifts, depending on our run rates. Just like in every area of the plant, when our gunners pull samples from these loaders, they're on the lookout for minor to major quality defects, and especially any anomalous data we generate with our test equipment. Some of the hotter magnum loads, the barrel may take a shift, and we have to be able to identify whether the load really needs adjusted or if it just needs retested quickly so we can reduce downtime. Our mission in ballistics is to make sure that every box of ammunition that leaves this factory is exactly what the customer expects it to be, and ultimately that it's a safe box of ammunition.
This facility I'm sitting in here, we're all in here today, this was built in 2015. It's our state-of-the-art evolution in ammunition manufacturing. Primary focus in here is 9mm ball ammo. So we know that the consumer is interested in a quality product that's affordable, and one way to keep it affordable is to make sure that your cost to manufacture are keeping up with the competition. So we dedicated an entire facility to that particular round because 9mm outsells every other FMJ round on the market 20-1.
From a rifle standpoint, Remington has extensive capability. It's impressive to walk the plant here and see how much capability we have, all the while maintaining a lot of flexibility within the product manufacturing lines to create various cartridges all the way from 223 Remington to 338 Remington Ultramag. As we've had the opportunity to put dollars and raw material back into the plant, we've seen all these machines come to life. We've seen the staffing come back and seen the product that we can make, and it is really impressive to see how much product we can put through.
Remington, of course, has seen its struggles like a lot of other storied brands, and I think staying true to who we are at Remington, true to core, but being able to push that brand forward and making it more energetic, more innovative, and first off, getting product back on the shelf is going to go a long ways towards helping Remington kind of gain back its cachet and its strength.
We are innovators. The customers depend on our brands to bring them the best, latest, and greatest products. That wasn't the case when we acquired Remington. You know, I think in the 3 years prior, you know, during the ammunition slowdown, if you will, a lot of companies pulled back R&D spending. I think that's a nearsighted mistake. So during the slowdown, we doubled down on R&D because this surge isn't going to last forever. When this surge ends or slows down, we have the R&D pipeline to really bring it to the consumers.